Hello, everyone. We came out with a superb idea to revolutionize healthcare to ensure the safety and well being of the population. I know it's quite a bold statement, but here at VM we have the proof to back up our claims, and inshallah you will see for yourself. Injuries can be caused by many activities done throughout our daily life. Many of those significant injuries are identified too late or simply left undiagnosed. These statistics were taken from Bayanat.ae, and as you can see throughout the years, the number of injuries are decreasing ever so slightly due to the advancements in technology, but nonetheless, we're talking about at least 100,000 people. It's true this makes up of only 1.2% of UAE's population, but this number can be reduced significantly throughout the usage of our proposed technology. After all, this 1.2% could include our family and friends. The world's population is about 7.42 billion people, and nearly 70 million people were diagnosed and receive medical treatment worldwide. But let's take a moment to think about all of those who haven't received treatment. I can say with all certainty that the untreated number of people exceed those who were treated by a huge margin. What we are proposing is video magnification that works by magnifying the changes in motion or color which is unseen by the human eye, just like when the blood is flowing within the human body. This is done by taking a standard video as the input and breaking it down into many smaller sequences. Then, we take the sequence and apply a filter to extract the blood flow rate. The extracted rate is then amplified and added back to the original reconstructed video. Here's an example of a video recorded input. On the left, you can see the pulse rate after applying the algorithm, and on the right, you can see the face changing color when the blood is circulating. Video magnification can be used to recover sound from videos, detect and extract blood flow from the body, and it can amplify tiny movements such as the baby's breathing pattern. Let's not forget that it can also extract the heart rate, which is as accurate as a standard heart rate monitor. The extraction of vital signs such as the heart rate and the blood flow rate from several body parts using video magnification has been in many researches. Here's three published researches that have tested the extraction of vital signs using video magnification, and they've gotten pretty accurate results. Another research has proved that detecting and visualizing injuries using image scanning techniques is possible. In this research, they use canny edge and thresholding approaches. The two main ways of diagnosing injuries are physical examination and scanning techniques, such as X-rays, MRIs, and CT scans. Patients tend to delay their visit to the doctors until the pain becomes too unbearable, since it's costly and not everyone is insured. The objective of this project is to develop an application to give a primary diagnosis to injuries in real-time manner without the need for any external equipment. Nowadays, nearly everyone carries a smartphone with them, so we do not need to buy extra equipment that can be used as a first aid device. Generally speaking, many people face minor injuries such as falling on their elbows or knees or even twisting their ankle while walking. Unfortunately, they do not give these kind of injuries any importance. By using our solution, a mobile application will give an indication of how severe the injury is, and if it really requires any medical attention or if it just can be treated using home remedies. Our intelligent approach requires a smartphone, which everyone has. They can simply record a short 30-second video of the suspected injured body part. Once uploaded to the cloud, our application will run a video magnification technique to confirm that the body part is in fact injured by measuring the blood flow rate and notifying the user with the results on their smartphone within approximately 60 seconds. Our technique provides a cost-efficient, real-time primary diagnosis. Our application will give an indication of how severe the injury is, so we can call it a primary diagnosis for injuries in its early stages. Redness caused by the increased blood flow in the injured body part is usually tougher to spot in people with darker skin tones, but by using color magnification, redness is easily visualized, and the vital signs will be easily measured. This block diagram shows what is required in this project. Basically, we have a mobile application for the user to interact with. This application is connected to a database which can send and receive information from the database. The database is also connected to Python, which contains video magnification algorithms. The database can also send and receive from Python.
This flowchart explains our implementation of the application, which is programmed via Flutter. As you can see, that there is a wrapper block which is going to actively listen to all authentication changes. So whether the user is logged in or logged out, depending on that user's authentication status, the wrapper widget is going to show a home screen or authentication screen. In the authentication widget, you have the register page, signing in page, and the application authentication is linked to Firebase authentication services. So you should have a valid email and password. Also, you should have an account in our application. And after registering to our application, the wrapper widget or the wrapper block will show the home screen where the instructions are. Those instructions are crucial to avoid any error measurement. Then you will go to the upload page where you upload your video of the suspected injured body part to the Firebase storage. Then you will go to the results where you can see whether you need to see a doctor or not. As you can see, this is how our application looks. As I mentioned, it consists of a registration and signing in page, also a home page, upload page, and results page. The developed algorithm or the processing algorithm is shown in this flowchart. So firstly, we read the video from Firebase storage. Then we apply a machine learning algorithm to detect the suspected injured body part. After this step, we apply two different video pyramids, which are Laplacian and Gaussian video pyramids. Then we apply a fast Fourier transform filter to extract the bands of interest. And then we amplify it and add it back to the original video frames. Then we get a plot flow rate reading from each video pyramid. And finally, we take the average of both readings to get more accurate results. A very important step is that we need to detect a body part, because the developed code should focus on a body part rather than focusing on the whole image and obtaining unnecessary signals that may act as noise that corrupts the measurement. We used machine learning algorithm which is called Hard Cascade, which is used to detect objects of interest. Here, as you can see, the Hard Cascade detected my face and my hand accurately and successfully. Here is a part of the processing algorithm. So at your left hand side you can see the reading video and detecting object code. After detection of a body part, the video will be processed using two different pyramids on your right hand side, which are the Laplacian pyramid and Gaussian pyramid. Later, blood flow rate can be measured for each video pyramid after applying the radio magnification algorithm by specifying the frequency of the maximum peak in the frequency spectrum. And finally, we take the average of both readings to get more accurate results. And now I will show you a video of our project in real life. Here you can see a comparison between the original video and the output video after using color magnification. Color magnification can clearly show the blood circulation through faces and hands and body parts, and hence the vital signs can be easily extracted. And here you can see a comparison between an input video and the output after using motion magnification on our wrists. The blood circulation through the veins is very clear after using motion magnification. It has been proved that due to this circulation, the vital signs can be measured accordingly. We tested the system on 14 video samples. We used physical sensors such as Apple Series Watch or the smartphone sensor to measure the blood flow rate or the heart rate. And then we applied our algorithm to compare between them. And we concluded that the system achieved 95.07% accuracy. What makes our idea original is that it has never been implemented before using a diagnostic first aid device using a smartphone only, without the need for any external hardware by using video magnification algorithm. Not to forget that the cost for consultation is very expensive and high. which makes this project highly cost-efficient primary diagnosis using a user-friendly mobile application only.